Hello everyone. Today I would like to look at a question on sequences and series. A circle with radius 6 centimeters is drawn. A second smaller circle is drawn. Okay, before I continue, I want to put that on my diagram. 6 centimeters. This is 6 centimeters. That's the radius. And then there's a second smaller circle drawn through the center of the first circle and also touches the first circle internally. So this is our smaller circle. Right, passes through the center of the bigger circle and then touches internally. They are referring to this point here. This distance is also going to be 6 centimeters. I'm going to put 3 centimeters there. Okay, I'm sure this is now a pattern. Looks like even the third circle is drawn through the center of the second circle. Let's keep reading and see. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. Right, so since we say this is 3 centimeters, it would mean that the radius of the next one is going to be 3/2 centimeters. And if you analyze this, we have 6. In fact, we're now creating a pattern. We have 6, 3, 3/2. We seem to be dividing by 2 each time, meaning that our constant ratio in this case is going to be half. And we can confirm that also by dividing term 3 by term 2, and we also get half again. Write down the radius of the third circle. All right, we've done that already. Radius is equal to 3/2. Calculate the sum of the areas. Now they're bringing in a new quantity. Areas of the first 10 circles. So this 10 obviously is our n, the number of areas that we're going to add. Let's start with area 1, the big circle. By the way, area is pi squared. It's going to be pi, and we've already established that the radius is 6 centimeters, so it's going to give us 36 pi. And then the area of the second circle is also pi squared. In our r, we said is 3 squared. Area of the third circle, by the way, this is 9 pi. And then area of the third circle, which is pi, and 3/2 squared, I believe this is 9/4 pi. Okay, this continues. I suspect that this forms a pattern also. Could be geometric, but let's confirm that these are the first 3 terms of the pattern. Okay, we're obviously not expected to calculate every single area. Now, since I'm suspecting geometric, I just want to divide term 2 by term 1. When I do that, I get 1/4. But I need to confirm that also and divide term 3 by term 2. Okay, just to be sure, just to do my due diligence. I'm also getting 1/4. All right, so confirmed is geometric, which means the sum of n terms is given by this formula here. And we're going to substitute. This is now S10, and it's 10, it's given. The first term is 36 pi into r, that's 1/4, okay, to the power 10 minus 1 over 1/4 minus 1. Right? Rest is a job for a calculator. My calculation gives me 150.80. This is the sum of the areas, and radius is given in centimeters, which means our units are centimeter squared. Okay, that's out of the way. Next question, which circle has a diameter of that? So it seems like they're switching it up again. They're changing the game again. Now we're dealing with diameters. Originally started with radius, then we came to area. Now it's diameter. Anyway, we had a radius of 6 initially, and then 3, and then 3/2. And we know the relationship between a diameter and a radius is that the diameter is double the radius, meaning our pattern of diameters has 12, 6, and 3. I'm multiplying each of those radii by 2. Okay. Now, this is obviously another pattern with the constant ratio of half. And somewhere down the line here, we have a diameter of 3 over 28. 3 over 128. So this is a term, meaning that's basically Tn. And this question is actually asking for n, the position of that circle in this pattern. Right? Tn is a to the rn minus 1, is 3 over 128. And then a is 12, r is half, 3 over 128. And we divide by that 12, half to the power n minus 1, 1 over 512. Okay, so moving on, at this point, you could use change bases, make bases the same. Right? If you decide to take that direction, you end up with 1 over 2 to the power n minus 1 is equal to 1 over to the power, this is how you do it in your calculator. You know that shift factor function, but you don't put the reciprocal. You just type in 512, and then you do shift fact, you get 2 to the power 9. So you know that this is going to be 1 over 2 to the power 9, meaning n minus 1 is equal to 9, n is equal to 10, right? But since you guys are in metric, it's better that you cozy up to logs. So I'm going to also use logs. Right? When we use logs, we are going to first of all write what we're trying to solve for. The exponent, you always start by writing exponent n minus 1 is equal to the logarithm. A logarithm needs to have a base, just like a power has a base. Our base of the power, which is half, becomes the base of the log, 1 over 2. And then we have that. Okay. And I'm certain that this is going to give us 9, meaning n is equal to 10, right? The question says, which circle has a diameter of 3 over 128 centimeters? So our conclusion is that circle number 10 has that diameter. Okay, so this is how you'd approach a question like this. I hope this is helpful. Until next time, goodbye.